Hi there. Before we get into these not so beautiful graphics behind me, I'm going to give you some analog presentation, just kind of talk through what these data are. We're looking at nitrogen management planning data. You're the ones who report them, and you know if you're in a high vulnerability area, the amount of nitrogen you apply, the type of crop you grow, the yield you're getting, those things all eventually get rolled up into kind of a general report by the coalition and sent to the regional board. So that's one use of those data, is just to satisfy that requirement. But another use of those data is to understand ourselves the patterns of our nitrogen use and what we're getting for that nitrogen. And so we've kind of looked at the nitrogen management data that have been reported by growers on about 1.6 million acres of highly vulnerable area in the Central Valley, and looked at them from a more agronomic perspective and production perspective. So that's what I'll be sharing with you. So let's see. So some caveats about these data. These are not experimental data. These don't come out of experimental plots. They come out of real fields. They therefore contain all kinds of variability that's introduced by management factors that we don't even know about because they're not part of what you report. You're not required to report those. So there's no association for existence, for example, with the type of irrigation system, type of soil things are being grown on, none of that. So when you look at these, when you just plot the nitrogen applied versus the yield obtained for pretty much any one of these crops, you see a big shotgun blast of points. And it's completely unlike experimental data where you're trying to figure out, appropriate nitrogen rates. So that's a challenge. And so one of the things that we've had to do to try to unravel what's the story maybe being told by these data is we've had to use some kind of crude smoothing techniques. So you just kind of divide the data up into bins. You get rid of some odd values that just look too strange and therefore may confuse things. And then you do some averaging over various ranges, and pretty soon things come into a little bit more focus. And so the way, in addition to the things you report, right, you're reporting yield, you're reporting nitrogen applied, there are other parameters that can be estimated. So for example, from yield, you can get the amount of nitrogen that's being pulled off your field in your yield just by multiplying your yield times a standard nitrogen concentration, be it almonds, corn, whatever. You can always convert that into nitrogen. And one of the reasons we want to do that is that's kind of a good check on how we're fertilizing over time. Another reason is that the regional board is looking at that same number very carefully, and so better that we look at it too. So you've heard a lot, I think probably Eric and others, talking about the relationship between the applied nitrogen and the removed nitrogen. So that was really something recommended to the regional board as a metric, but it was recommended by growers and agronomists because over broad areas over time, if that number gets smaller and smaller, it indicates that we're being more efficient in general with the use of nitrogen. So that's, from water quality perspective, a good trend. Probably economically, it's a good trend too, so long as we keep producing good crops. The other thing you can do is you can just take the difference between those two numbers. So if you take the amount you apply minus the amount that you remove, well, that's kind of an index of the amount of nitrogen that's subject to loss. Now, lots of things can happen to that nitrogen. It can get tied up in organic matter, it can wind up in your wood, in your leaves, and get recycled. It can be denitrified and become nitrogen gas, but it is subject to leaching. It could be leached in the event of a big irrigation or rain event. So it's kind of broadly used, well beyond California, as an index of risk associated with the use of nitrogen. So if you have it's called the nitrogen balance, and if you have a big nitrogen balance, you have 100 pounds, It's you put on but isn't removed in your crop. That's subject to leaching. Now it may be that none of it leaches, maybe that 5 pounds of it leaches or 95 pounds of it leaches, but if you have a nitrogen balance of 0, then, which is hard to do, then you have less nitrogen subject to leaching. Okay, so that's a simple idea. So the way we've kind of struggled with how to visualize these data, we've got 3 plots, and excuse me for really just showing you a bunch of XY plots. They're not super complicated once you get used to them. We're looking at almonds first. There will be about a dozen crops we'll run through here. The plot that's on your left is just the distribution of what people are doing. So the vertical axis there is just total acreage. So what you see there is you've got the lion's share of growers are applying around 200 pounds. You see that nice peak over 200 pounds, and then it kind of tails off to each side. So seeing the distribution of what people, that's really a behavioral graph, and what it tells us is that there seems to be kind of a consensus among almond growers that that's a pretty reasonable rate given the yields that we generally expect. So that's interesting. Some of those points that are colored yellow, we sort of flag those as points that we shouldn't pay too much attention to because there just aren't a lot of acres in those classes, so we're not really sure what's going on. The second plot, the middle plot, is more like the classic yield response curve, and so that's yield on the vertical axis and applied nitrogen on the x-axis, and really alone among the crops, the almonds have a fairly nice yield response, the kind of thing we expect to see in a classic experiment. And so really, if we're putting on more nitrogen, we better be getting more almonds, right? That's the whole idea. And you also see in the almonds, it's in these yellow points, so we're not as confident about them, but you begin to see things kind of tail off. In other words, on that right-hand end of the middle graph, you begin to see that increase really levels off. Now we're putting on more nitrogen, and on the average, we're really not getting that many more almonds. That's often what we see when we do experiments, right? It's just, there are other things that limit the amount of tonnage you can get. That's why we have a finite yield potential, right? Other nutrients, diseases, weeds, just the physiological ability of that canopy to make almonds. So you're always going to see that if you go high enough with your nitrogen rates. So there's kind of the prettiest version of what we get out of these NMP data right there. And I have no idea why that's true of almonds. Now the right-hand graph is different, and so the first one is just distribution of what people are doing. Second one is yield. The third one is this nitrogen balance I was talking about. So that's the amount of nitrogen that's subject to leaching. It's the amount you apply minus the amount we know you're taking away in your crop. Doesn't mean it's leaching, it just means it could. So it's an index of risk. So I'll refer to it kind of that way. And the characteristic of this plot that I think that I didn't fully anticipate until we looked at these data is, although the first and second plot vary quite a bit from crop to crop, that right-hand plot is almost always shaped pretty much like this. So what that tells us is that every time we put on another pound or 10 pounds of nitrogen, we increase this index of risk. So when we put on nitrogen, it's a weighty decision, right? It costs us money. It's what we need to get ourselves a good yield. But as we put on more and more, we have an increasing risk of losing that nitrogen to other places we don't want it to go. So it's something to be careful about. So I think we all know that, but that was an interesting finding. So now we're going to whiz through, basically look at the same 3 plots a little quicker, but for another 11 crops. This is corn silage, and we'll see, patterns that I will admit that I don't fully understand. I'm not an expert on all 12 of these crops, and really, I think what needs to happen here is that these data need to, as we get to 2017 data, and we start to see how they change over time as we get those in. Really, they need to be studied by each commodity group and each community of growers and CCAs and the like. And those people who understand these crops really well will see things in these trends that people like me aren't going to understand necessarily, right? So this is really the beginning of a conversation. And I will note too, one thing I didn't mention. This is sort of momentous. You've seen lots of folks from cooperative extension and the industry come in and talk about experimental results and things we've learned in plots, and they show you graphs like this. Never, to my knowledge, have we ever had, not only here but elsewhere, a lot of information about how growers are using nitrogen. It's just not something we've ever had to report. So it's an inconvenience to do it. It's maybe unfortunate. It came with our regulatory program. We may not like it, but now that we've got it, it is a new day. Right? We know things about our community of growers and how we use nitrogen that we didn't know before. So anyway, let's see what that tells us about corn silage. Corn silage, there's less of a consensus about how to fertilize it. We have a big peak over 200 again, but we have some shoulders. Again, we have a climbing yield response kind of in the middle of that yield response curve in the middle. We're not really sure what's happening off to the right, why we're getting a whole bunch of corn silage without very much nitrogen. But that's not a lot of acreage, so I'm not going to spend a bunch of time trying to figure that out. And then we have a few acres off to the right, where, frankly, we're not sure why we've got such low yields. So these are things that may be anomalies in the data. They may be real things that we need to figure out, but they're there for us to kind of puzzle over. And then, as I said, on the right-hand side, although there's some jigs and jogs, in general, it's upward and to the right with risk as we use more nitrogen. Now we're moving on to cotton. Cotton, again, sort of a lot of people clustered around 180 pounds. You've got the yield response is as confusing as anything I've ever seen, but it is what it is. We can't fake it. I think industries like this are going to need to sort of look at this over and try to figure out what it means to them. If you're not getting more yield than in general, then there's kind of a question: is this a sound practice? And there may be a perfectly good explanation for this that Bob Huntmacher and our cotton growers can really kind of enlighten us about. But that's sort of part of what's ahead of us, is having all those discussions within the industries so that we can figure out where we want to go with this. Now we're moving on to oranges. Oranges, another kind of consensus around 120 pounds of nitrogen, another nice climbing leg. Some funny things happening over in the low end in terms of yield. And then we have in the high range of nitrogen application, we really have kind of an uncertain response in terms of yield. So a recurring theme you're going to see is kind of in the middle where we got a lot of people, a lot of acres. It sort of looks like we're getting often a fairly solid yield response, with the exception of like cotton, for instance. But as you get to the high end, that response becomes often very uncertain. And so then there's, if we're looking for a way to get better in front of our regulators and make our industries more efficient, we ought to really be looking hard at those acres. And if you're over there, or somebody who's over there, and you've got a yield goal that is really, really high, you got to ask yourself, is that yield goal realistic? And am I fertilizing, a real crop or one that I just hope for? If you're over there and you're getting very high yields that are commensurate with your nitrogen application, then you're in the right spot. Now we're moving on to pistachios, and so some of this kind of, you think about the story of each of these crops. Pistachios, a slightly newer crop. I think there's a certain amount of uncertainty about how to grow it. We grow it on some really bad ground, so it's alternate bearing. So we'd expect to see due to all those factors, kind of a broader range of management. Some of it well-informed, some of it maybe experimental. So, and that's exactly what we see in the applied nitrogen. We see a pretty broad range between 100 and 200 pounds. Then we look at the yield response, and we do see a yield response too, but across that 100 to 200 pound range, we get kind of a flat response. Again, pistachio is such a complicated crop with all the variation in the growing circumstances that, you know, that may be easily explained by agronomic factors that, you know, we just don't know. They're not in the data set. Moving on to potatoes. Now, as Tim indicated, you know, row crops are a whole different beast, right? You can get shallower roots, potatoes are on sandy ground, so they're a hard one to deliver nitrogen to very efficiently, and it kind of shows up, you know, really high nitrogen rates, the highest rates in 275 or 300 pound range, and then, but at that most popular fertilization rate, you're not necessarily achieving your highest yields on the average, right? That doesn't speak to any individual field, but on the average. And so that's just kind of some of the hardship of trying to fertilize a shallow-rooted row crop on sand. Now we're looking at raisin grapes, and you know, one of the things I know about raisins is that a lot of them are grown on areas that you get a lot of nitrogen out of their irrigation water. This kind of wild distribution, broad distribution, could have something to do with reporting, because not everybody always reports what's in their irrigation water, even though you're supposed to. So I'm not really sure what's going on there. Across that range, the yields are also kind of jagged. So I think that's an interesting set of data for the raisin industry to ponder and learn from. And you know, when we get the 2017 data, they may look completely different. You know, the story may be that this is a weird year for raisins. Who knows? Table grapes. Table grapes is a little more of a consensus crop. You've got kind of a broad range of what's really happening, but a lot of folks clustered right around 80 pounds. And then, you know, kind of a yield response and then a bit of a plateau. So again, I mean, if I were a grower that were off in that high range, I'd be saying, so am I one of those guys that's putting on a lot of nitrogen, not necessarily getting that much more than the guy who's putting on 40 pounds less? I don't know. If I am, I might rethink it. Those are potential opportunities if they exist and where they exist. Now tomatoes. Tomatoes, another, you know, we've been farming tomatoes for a long time. There's a lot of consensus around this 200, 225 pound range and a kind of solid yield response, but then again, sort of erratic kind of yield trends across that range of between kind of 200 and almost 300 pounds of nitrogen. Walnuts, and so walnuts are another interesting story. You know, the recent research on walnuts is that you can get a pretty good crop of walnuts. Really, they don't need as much nitrogen as we once thought. So the nitrogen recommendation has been revised down by, I don't know, 60 or 80 pounds or something like that. And so what you kind of see is you see some folks sitting up at that old recommendation rate, and then kind of the lion's share of the industry having migrated to lower rates, and a lot of them getting fairly comparable yields. So I think that's just an industry potentially in transition as they learn more. Wheat silage, you know, I think we may be looking at residual nitrogen from other crops here. I don't know, a lot of it's double cropped with heavily fertilized stuff, but you've got a broad range of nitrogen rates, and you've got a fairly consistent productivity. So that's kind of the picture for wheat, and I think that's our second to last. Yeah. And then wine grapes. Wine grapes not heavily fertilized, as everybody knows, but you know, they do kind of climb up into toward 100 on the high end, and a bit of a yield response, and some odd things happening at those very high rates. Who knows? So I think my message is that, you know, we can probably learn a lot from these data. I think it's going to take us time to figure out how to interpret them. We need the engagement of you know, your CCAs, your PCAs, you know, growers who are very familiar with their own crops in some specific situations, cooperative extension, commodities groups. I think it's kind of a team effort, and it's really just hardly begun. We haven't had these data in our hands very long, and so I think it's a conversation we need to start to have. But here are some things I think we can already take away from it. I think that it's pretty obvious, and we've always known that realistic or accurate yield goals are good yield goals, that you know, using everything we know about our crop history, our outlook for the year as far as water supply and things like that, that all ought to be taken into account as we move to fertigation systems, and we can actually make more real-time decisions about nitrogen management in those situations. We can look at how the crop's developing and sort of adjust along the way, and got leaf tissue sampling and tools like that that really should help us out. And so dialing in our rates based on what we really think our maximum recovery, and dialing in our rates and maximizing our recovery of applied nitrogen by all the practices that Tim discussed and more, is really kind of our long-term mission when it comes to irrigated lands. And there should be really solid production benefits to this. One of the orange growers I know well this year kind of just totally rejiggered his fertigation, just smaller applications, more frequent applications, used to the pound the same amount of nitrogen, and you know, didn't have, you know, I don't know what else happened, but that was the major change, and he had a much nicer crop. And so there's a situation where it is really nice. That's the kind of outcome we want, is where he didn't change his nitrogen rates. That wasn't the thing he needed to do to get better. He just needed to get more of it into his crop, and if he can figure out how to do that year after year, he's going to be better off. So, you know, all the other well-known kind of approaches, soil testing, so you know what there is in your soil, and you can account for that. And don't forget to account for what's in your irrigation water. We've got now, I think, 4 different irrigation water nitrogen calculators out there. If you're an analog person and you want to do it with pencil and paper, there are instructions on how to do that that are just on one page. If you're a lookup table person, there are lookup tables. You don't need to pull your calculator out. If you're a computer person who wants to work a field at a time, there's a little calculator like that. If you're a batch person and you want to download a spreadsheet and run it for 100 fields, you can do that. They're all out on our website. And just go grab them and use them. That's what they're there for. And you know, the regional board, once they understood that we've got nitrogen in our irrigation water, and sometimes people ignore it, that's a real hot button for them. So we'd like to be able to tell them that, no, every grower takes account of the nitrogen in their irrigation water before they buy their fertilizer. That would be the ideal situation for us as a coalition and as industries. And then you know, we got to think that once we do the things that really improve the recovery of applied nitrogen, we got to, one of 2 things has to happen. Either we got to get a bigger crop to take up all that nitrogen, right? Like my orange friend, or if we can't get a better crop because our crop's not growing and we've got other things, then we've got to dial down our nitrogen rates because we just don't need as much anymore. That's pretty simple. Anyway, that's kind of what I had to share today. We'll update you as we learn more about these, about your nitrogen management planning data for 2017. And you know, we'll be talking to talk to your CCAs, talk to your commodities groups, talk to one another, and you know, let's kind of figure this out and use these data to our own benefit.